Hello, welcome to SMT Call. Today we are going to solve the day 8 of August LeetCode challenge. So today's problem name is path sum 3. Basically, if you read the problem statement, it's saying that we need to, so you will be given two input. One will be the tree, and that basically you will be given one root node, and we will be given another integer called sum, right? And we need to find the number of paths that sum to a given value, right? So basically, if you check this tree, you can see that there are multiple paths that will produce. If we add the value of those two nodes, it will produce the given sum, right? So suppose our given sum is 8 here, and if you traverse the tree, we will always consider sum from top to bottom, right? Not from bottom to top. Okay, so if you see this tree, you can see that if I traverse this portion, these two, if I add these two three nodes 5 and 3, it is producing 8, right? So if I add these two nodes, then that will be 8, right? So that can be one node. Another one can be 5 to 1. This one, it is also producing 8, and another one is minus 3 and 11, right? It's also producing 8. So we need to return 3. So these are the three possible paths that will produce sum 8, right? So we need to calculate that. So then the algorithm using which we can solve it. So what we can do, so basically if you think, so there are multiple ways to solve it, right? So what we can do, so probably I can take one list. Okay, in that list I am going to maintain all the tree nodes, right? So at first I will traverse the left, then I will traverse the right, then I will then one by one. So since we need to always consider top to bottom, so let me draw a small list here. So probably this is my list. So I will start traversing from the root, and I am going to insert that node in our list, right? Then 10, then 5, then 3, then 3 again, right? So I will stop once I found that once I found a node that left and right both children are null. In this case, I will stop iteration or I will stop my recursion, and I will now what I will do. So I have these four nodes or value, right? Now I need to check that is there any possible combination of the given sum. And so since we need to do from the top to bottom, so what I will do, I will start from my bottom only, right? So suppose that, okay, so let me mark it out here. So yeah, so we covered this portion, right? So so what we have done, so we will cover this portion first, and I will check that is there any possible path exist or not here, right? So how we can check? So since we need to consider top to bottom, so I will start from the end of our list only, right? So I will do 3 plus 3. Is it our given sum? It's not, right? 6. Then I will move further. Then I will add 5 here, right? Again, it says that it will be 11. So it's not matching, right? Again, I am going to add 10 here. So I am not able to find anything, right? So once we are done with this, so once I will say that for this path we don't have our required value or required sum, then I will going to delete this portion, right? I am going to remove the 3. Then what I will check? I will check for this location, right? 10, 10, 5, 3, right? Then again for 10, 5, 3. So what I will do, I will go to the right side now. So I will going to add 10, 5, 3 minus 2, right? Again I will try to calculate that is there any possible path. Again I can see there is no possible path, right? Minus 2, 3 is 1, then 6, then 16, right? It's not giving me our sum, right? So again I will going to remove that minus 2. Now I will check for this section only, 10, 5. Now I will check for this section only, right? 10, 5 and 3, 10, 5 and 3. Again I can see there is so there is one path exists, right? So since we are considering from the end to first of the list, so I can see, okay, 3 and 5. If I add these two, then I can get our required sum 8. That is 8, right? So I am going to increase my counter. So my counter will be 1, right? Counter will be 1. Okay. Now again I will once we are done with this, so I will remove the 3. I will remove from the end. Again what I will do, I will add 2 here, right? So I will add 2. Then again since we are going to till the depth, so after 2 it has one node, right node, that is 1, right? I am going to add that. So my array or list will look like this. Now again we will try to find that any possible sum is there or not. Again we can see, okay, we have one sum, right? Again, so I can add 1, I can add 2, and I can add 5, right? So that's giving me 8, right? So I am going to update. So I found 2 possible paths, so my counter will become 2. Now what I will to check, so again once we are done with this, so this section, so now we are in this section, right? We visited this section only, right? This and also 10. Okay, so we visited this portion 10, 5, 2 and 1, right? Now once we are done with the 1, I will going to remove the 1 from here, and again I will see that is there any possible combination. Again there is no possible combination, right? Then I will again remove 2. Then again I will remove, I will check for 10 or 5. So there is nothing for 10 or 5, right? So I am going to remove 5. Then again I am going to insert -3. Then again since we are going till death, so I am going to insert 11 once again, right? So again I can found there is 2 possible combination, right? One is 11 and one is -3. Okay, so that will make our sum 8. So I will going to increase my counter once again, and it will become 3. Then again I will remove 11 and I will check for is there any path for 10 and 3, 10 and -3. Again I think no. Then we are going to stop it, right? So that is the approach we are going to follow, and we are going to return the counter here. So let us write the code in Java. That will give you more better understanding, and I will give you code walkthrough after writing the code also. So what I will do, so I need 2 things. So I need one counter. So let me declare it in global, as global variable, since we are going to reuse this in our other recursive function also, right? So int counter should be initially 0. And what we can do, we need to keep track everything in a list, right? All the nodes. So we can take integer, list integer, and we can initialize that new linked list, and it will be generic types. Okay, so now what I will do, so we are just call our recursive method. So probably name it as calculate sum, and we are going to pass 2 things. One is root and another one is sum. Okay, so we are going to pass these 2 parameter, and once we are done with our calculation, we are going to return our counter, right? So since counter is a global variable, we can directly return here. Okay, now what I will do, I need to implement this calculate sum method, right? So let's implement that. So private, we are not returning anything, so it will be void, and let me name it as calculate sum only. Okay, so it will be calculate sum, and we are passing 2 parameter. One will be tree node, and that will be node, you can say it node, and we are going to pass the sum also, right? So the actual sum with which we need to compare, right? So right now what I will do, so since I was saying that I am going to take, so I already declared my list. This is my list, right? So I already declared the same, and I will traverse till I found all the nodes are null, right? So whenever I will found the null node, null child node, in that case we are going to return, we are going to stop executing that function, right? So let's add that condition. If node equals to null, then we will return, right? Since this is a void, we can write like this, return. Okay, else what I will do, I am going to add that in our list. So it should be node dot value. Since we are considering the value, so we are going to add value only in the list. Now what I will do, so now I need to traverse. So I added my first node, right? So let's take on the first. So I am here now. I added 10 in my list. Now I am going to traverse till I found both the child and null, right? So li dot, sorry, it should be calculate sum. We are going to call the same method, right? Recursively calculate sum. Then again we are going to pass 2 things. One is the node dot left. So we will at first do it for left, then we will do it for right also, and we are going to pass the sum also, right? Similarly, we need to do it for right also. Calculate sum. Again, this time it should be node dot right, and it will be sum. Okay. Now what I will do, so after the first iteration, how it look like? So it will look like 10. Then again it will come to 5. Then again it will come to 3. Sorry, 3. Then again it will come to 2, right? So this is how it will looks, right? Because after that it will return, it will stop here, right? It will returning this. Okay. So now what I will do, now I am going to take what temporary variable, int probably temp sum, something like this. Initially it will be 0. Now what I will do, I am going to iterate through this list, and I am going to see that is there any possible sum exists or not. I am just going to add this number, right, and I am going to find that is there any possible sum or not. So let's do that. So let me take one for loop here, and again I will start from end. So int I should be, or int L should be li dot size, and it should we will start from end, and since our index is from 0, it will be -1, and L should be greater than equals to 0, and again I am going to do L minus minus, right, since we are decrementing. So now what I will check, so I will check, so I am going to add my temp sum, right. So temp sum equal to temp sum plus whatever the value is, right, li dot get L. Okay, so I'm starting from the end, right. So I will pick the 2 first, and I am going to add it, right. 2 plus 0, it will be 0. So and I'm keep checking after calculating temp sum. I will keep checking that is it equals to my actual sum. If it is equals, then I am going to increment my counter, right. So if temp sum equals to counter, then we are going sorry, it should be sum, right. So if temp sum equals to sum, then we are going to increase our counter, right. So counter would be plus plus. Now what happened, so at first we will do it for all these 4 number, right, and then once we are done with that, we are going to remove that number, right, from the end, because there is no possible combination and we need to consider top to bottom. So I can remove the last element or last node, right, then we can try for the other elements. So we are going to do that. So we are going to remove the last element from our list, right. So it should be li dot remove, and it should be li dot size and -1. So that's enough, I think. Then what we will do, we will going to remove the last element, then we will try for other combination, right, 10 5 3, then -2, like that, right. And I think that's pretty much, then it will work recursively. Let's run our code and check it's compiling or not. Yeah, I think it's giving me some error. Let me fix that. Okay, it should be counter. There was a spelling mistake. Let's run it once again and check. Yeah, I think it's giving me expected answer. Let's submit our answer and check also. Yeah, I think the solution is accepted. So let's do some time complexity analysis and code walkthrough also. Let me copy the code quickly. So let me copy the code. Okay, so what we are doing here, let's check. Okay, basically we take this, we initialize this list, and then again we initialize one counter in which we are going to keep track the number of unique paths, you can say. Now what I will do, I'm just going to, I created one recursive function named calculate sum, and I'm going to add every node in that, every node value in that list, and I'm for till we found the null, right. So initially it will go till 10 5 3 2. Then we are going to check that is there any path exist for that corresponding combination. If no, if yes, we are going to increase our counter. If else, after checking for all the elements, we are going to remove the last element, and we are going to again move further, right. We are going to insert again right, and then again left, right, something like that, right, recursively, and recursively we are finding all the possible sum, right. And okay, so and what will be the time complexity for this? So we can see that we are using one extra space, that's list, right, and its size will be n, right, since we are traversing each node once. So in this case, space complexity will be order of n, and time complexity will be also order of n, since we are traversing each node only once, right. I think that's pretty much for this video. If you like this video, please share it with your friends, and I am going to add the code link in the video description also. Thanks for watching. Bye bye.